Hello and welcome, guys. Today we'll be implementing a stack from scratch in C language. Today we'll be focusing on the practical part, that is the programming implementation of stack. So I assume that you guys know what stack is and you know what the operations in stack are. So we are going to create a file called stack, and we will give it an extension of .c. So we will start now. So first we will include the header file, that is stdio.h. After that we define some constants that we are going to use. We'll use the value of true to be 1 and we will use the value of false to be 0. Then we define the maximum size of stack, which is of size 5, suppose. Then we define the structure of stack, and stack our stack is going to have namely two components. The first one is called top of stack, and the second one is going to be an array whose size is max, so that we can easily make change in our program. So we are going to create some functions now. The first functions we are going to create is called is full, which will return whether a stack is full or not. It will return true, that is 1 if the stack is full, and it will return false, that is 0 if the stack is not full. And it is going to take a structure pointer. It is going to take a structure pointer, let's say small s. Then the logic is very easy. The stack is full if the top of stack is at max minus 1, so we are just going to compare the top of stack with max minus 1. But since we are using the pointer of structure, we will write our logic like this. If s arrow operator top equals to max minus 1, then we can return 1, otherwise we can return 0, signifying stack is not full. We can do this, or we can very easily reduce the length of code. Instead of writing all this, we can use a conditional ternary operator. We can just simply return if by checking whether the top of stack is equal to max minus 1, and if it is true, then we will just return true, that we defined as 1 earlier, otherwise we will return false. Similarly, we can create another function called is empty, which will check if the stack is empty or not. And stack is empty if its top is at minus 1, so it will be similar as before, but instead of checking whether top is at max minus 1, we'll just check if the top is at minus 1. Similarly, we will define a function that is going to push element onto the stack. So the function is going to be fairly easy. So it will also take two arguments, struct stack pointer, and it will not return anything. And also it will take another argument called let's call it element. It will push the element onto the top of stack. So what it's going to do, it is going to at first it is going to increment the top of stack. At first it is going to increment the top of stack by 1, and then it is going to write a value to the new top. So at first it is going to increment the top of stack by 1, and then it is going to write the value at top of stack. So we can do this, or if you want to make it more concise, what you can do, you can use a pre-increment operator here, which basically does the same thing, and we can remove this line of code here. Similarly, we can write another function called pop. Now pop will only take one argument and it will return an element from the stack. So what it does, it will return the element. So we will just return the top element, and then we will decrease the top. So we can write post decrement operator here. And similarly we can also create a function called pick, which can be used to pick the element at the top of the stack without making any changes onto the stack. So instead of doing all this, we can simply return what we return in pop, but pop decrements the top stack, but pick does not decrements the top stack. So now we can jump to our main module. So we'll be using a switch case statement, and we will define two variables that are going to be needed in our program. So the first we will show an event driven menu, but before we do that we will define a structure of stack. Let's call it s. Let's call it s, and we initialize the top to -1. So this happens in every stack. So what we are doing here, this step is equivalent to writing code like this: s dot toss, that is top stack, is equal to -1. But in this case we are using dot operator because this is a structures object, and here we are using add operator because that is the pointer to the structure. So we will initialize the top to -1. After initializing top stack to -1, we will show an event. We will show an menu driven screen. So first we will show user something like whenever they press 1, we are going to show us option of pushing. Whenever they press 2, we are going to show them an option of popping. Whenever they press 3, we are going to give them option of picking, and whenever they press 4, we are giving them option of exiting the program. And we will take the input from the user in the similar fashion, and then we are going to store whatever they entered into a variable called let's call it choice, and we will perform a switch case statement on the basis of choice. So if whatever the user entered was 1, then we are going to push, but before pushing we should check if the stack is full or not. So I will call the stack full, its full function, and I'll pass the address of the stack because it is expecting the structure pointer, which is the address of a variable. So if this evaluates to be true, we will just print stack overflow, and then we will exit. Otherwise, if it is not full, then what we can do, we can ask for element that we want to insert. So we will ask for element, and we will store its value on, let's store its value on value. Let's store its value on value. So after doing that, what we can do, we can display a message like %d was pushed. We can display a message like this, and we can print the value. So after finishing else statement, we can perform break on the first case, and then we can write the second case, which is for pop operation, and we check if the stack is full on push, but we will check if the stack is empty before popping because we cannot pop from an empty stack. So if this happens, then what we are going to do, we are going to say stack underflow. We are going to say stack underflow, and then otherwise what we are doing, we are going to call a function that pops things. So we can simply write here printf %d was popped, and then we can pass a function call here. We can just call pop with an address to the structure, and we can perform a break operation here. And then let's go to case 3. So case 3 is similar to case 2. There isn't much difference between pop and pick. In pop we what we do, in pop we at first try to check if the stack is empty or not, and if it is empty we just write stack underflow, because we cannot remove anything from an empty stack. In case of pick, what we are doing, we are going to check if the stack is empty or not. If the stack is empty, then there is no element on the top, so we cannot see anything. So, and we can write message like %d is at the top. And the next thing you have to understand is that pick operation does not changes the value of the top of stack. The top is going to stay just the same. So in case of case 4 now, we'll just print a message that signifies that the program has come to an end, and we will break the statement as well. And in default cases, if the user does not enters any of the things, we will print a simple message like enter 1, 2, 3 or 4 only, and then we can insert a new line here, and then we can insert a break statement here. After doing all this, now let's close our do statement, and we want to repeat this until the user does not enters 4. So I wrote here while choice is not equal to 4. Now I am going to print an empty line here, and then I am going to return 0 as my last statement. So this is the entire program. This is the program that we did today. So now let's see if we have any error or not. So I'm just going to check that my program, whether I have any error or not. So my program is saved on desktop, so I'll just navigate to desktop. You guys can use any compiler you want to use. So I have a file called stack.c. I'm going to compile that file by using this syntax. And then here are some errors. I got an error on line number 34 and line number 35. So let me just quickly see what I have done here. So I forgot to write a bracket here. So, and again let me save the program, and again let me try recompiling. Let's just compile the program again. So this is a stack.c-o stack. Now let's run the program. So let's push 12. So 12 is at the top. Let's push 15. 15 is at the top. So if I wait to check the top, the latest element is going to be on the top. So if I check 3, you can see that 15 is the top. So if I were to pop, 15 is going to be removed, then 12 is going to be removed. So if I press 2, you can see 15 was top. Now 12 is at top. So if I again pop it, 12 is popped. Now again if I try to pop further, then the stack is going to show stack underflow condition, because there are no elements in the stack and we cannot pop from the stack. So it is stack underflow condition. So this is how we implement stack, that is last in first out based data structure, in which there is only one end, and whatever element you insert at last will be at the top. So thank you guys for watching this video, and if you want to learn more about stack, you can simply raise questions and give feedbacks in the comments. Thank you.